Hey everyone, and welcome back to the SaaS developer community where we learn to build SaaS applications from each other. And this week I have with me Gunnar Morling.
Hey there,
Gunnar,
hello.
Gunnar is previously the lead of the Debezium project, which we will talk about a bit today. And he is currently a software developer at Decodable. I think I met him when he started working on the Debezium project.
Right.
It integrated with Kafka.
Exactly. Yes, exactly.
Yes.
Gwen, thank you so much for having me. Super excited to be here. I'm sure this will be fun.
Yes. Okay, so basically, I invited you today just because I wanted to hear about different design patterns around event streaming and event processing, which you did
Right.
with the Debezium, and now you're doing it Decodable. But when we started chatting, you shared something really, really new and exciting. And I'm like, okay, dropping all my previous plans. Let's talk about your cool new idea. The world has to hear about it. So
That's awesome.
yeah, so let's get to it. You published an article in the InfoQ magazine, I guess.
Right.
So let's
Exactly. Let's talk about that one then.
yeah, tell me where it even gets started.
Right,
Like,
exactly. So, yeah, we had to, I mean, to give some context, right? As you mentioned, I was the project lead for Debezium, which is a project adjacent to Kafka, but also used with other streaming infrastructure, and it's therefore change data capture. So this means it extracts change events out of the transaction log out of your database. So that what it does whenever something changes in your MySQL or Postgres or whatever this database, something gets inserted or updated or deleted, then Debezium will capture this event and send it out to consumers via Kafka, via Pulsar, Amazon Kinesis, what have you. And it generally speaking enables all kinds of interesting use cases, right? And Gwen, we spoke about those before, like updating your search index, putting data from your operational database into Elasticsearch, or well, that's a search index into your data warehouse, maybe. For microservices data exchange, all this kind of stuff. And actually, then I came across an interesting feature in Postgres, which is those logical decoding messages, and I really got interested about it, and I thought, well, I feel like not many people know about it. And actually, I went even to Twitter and asked people, so hey, if I were to write an article about logical decoding messages, would you be interested? Would you be interested to learn what you could use that for? I mean, what is it and what you could use it for? And so that's how I ended up writing this article. And I guess the idea for today is we walk through this a little bit and we talk about some use cases for those Postgres logical decoding messages.
yeah, so you discovered the Postgres logical decoding messages. What are they?
Right. So I mean, to give a bit more context there, I mean, all those databases like Postgres and so on, they have what's called the transaction log, right? So this is the canonical source of truth of the database. Whenever an application writes to the database, it will be appended to this transaction log. This happens essentially for, well, two reasons. I would say A, for transaction recovery. So in case things go wrong, the database can restart and can reach like a consistent state again. That's the one reason. And then also it's often used for replication purposes, right? So if you essentially tap into this transaction log, and that's exactly what Debezium does, then you can use this to replicate the data from a database into, well, other representations of the data. And let's say also the Postgres internal replication mechanism is based on that. Now, what those logical decoding messages are is essentially just a way where you write messages just to this transaction log. And the interesting thing there is they will never show up in any table. So you just put something to the transaction log, but then you never can go to your table, to your database and query it, or run some queries against it. You would never find it. It's just there in the transaction log, but still you could use change data capture to extract those logical decoding messages from the transaction log and propagate them, react to them, process them, as we will see.
So I can write anything there? Like, would the simplest be like hello world?
Exactly right. So let's do this. Let's go a little bit into it. And I mean, I don't want you to read all this, right? But so I will focus on the
we
key
do.
parts.
There is going to be a link in the show notes,
Right,
so you could read
exactly.
through it.
Exactly. Then people can read about it after the fact. And by the way, we also have an example repo on the Decodable GitHub org where all the code is there, so you can play with that yourself. So right. So how does it look like? And let me go there. And first of all, you need what's called a replication slot. So a replication slot, that's essentially just like a handle which allows you, to say, okay, I want to retrieve changes from this database, and it essentially also keeps track of how far your consumer has consumed the transaction log. So that's the first thing. You need to have this replication slot. And then you can get changes from this. So there's Postgres functions for that. PG logical slot get changes, specify the name, and well, if you haven't done anything before, well, it would be empty. And now to answer your question, so how do you actually write such a logical decoding message? And there's another function for that, and that's PG logical emit message. And this has 3 parameters, and let's talk about the last one first. So that's your payload. And as you say, it could be anything, right? It could be a text, could be a JSON structure, it could be, I don't know, XML. It even could be binary data. So there's another version of that function where you can put just binary data. So let's say you were to use Avro or protocol buffers, you also could do that if you wanted to. So that's your payload. Then you have what's called the prefix. And the prefix, that's essentially just like a category of your messages. So there you say, you could say, that's like a specific type. Maybe that's, I don't know, logging messages or customer messages or whatever it is, right? So that's just a discriminator. So if you receive those changes, then you could ignore some of types where you are not interested. And lastly, you have this Boolean attribute or parameter, which is to say, is this a transactional message or not? And essentially, this just means if a message is transactional, then it will just take part in your transactions. And if you commit the transaction, this message will also be written. If you roll back your transaction, then the message would not be sent. So that's a transactional message, as you would expect it. And if you do a non-transactional message, so if you do false here, then if you were to roll back your transaction, this would still be written. So it always gets written, no matter whether a transaction gets committed or not, which allows for some interesting capabilities. So that's how you emit it. And then there's a few functions where you can get those changes. Actually, I see I should have shown this here in the article. So, if you were to call that again, then you would see this hello world text, which got inserted into a message. So that's how you insert them, and then you have a few functions where you can, for instance, just peek into a transaction log without advancing your replication slot. You could get binary changes. You could just advance your slot and so on. But that's the general basic mechanism.
Amazing. So, okay, it's pretty cool. I can write whatever I want, like
right.
hello world.
Why would I do that?
The question does come to mind, yeah.
Exactly right. So let's talk a little bit. Why would I do that? And again, I'm interested in this, and I'm not saying, okay, this is something you have to use, or like that's the only way how you should interact with Postgres going forward. I'm not saying all that or any of that. I'm just thinking it's an interesting mechanism and an interesting tool in your box. And there's, I feel, a few use cases which could benefit from that, right? So let's talk a little bit about that. And the first one would be the outbox pattern. So there, for the to give some context there, the I mean, what people often do in event-driven architectures, in microservices, they need to exchange data between their services, right? So let's say you have this typical e-commerce application landscape where you have a service for the customer domain, you have a service for your orders domain, you have an inventory service, and all this kind of stuff. And they all have their own local database, right? So you don't want to share databases between your microservices typically. And now the question arises, still, those services, they need to exchange data, right? So maybe this purchase order service, it receives a new purchase order, And then it also, it first of all needs to update its own database. So it would write this purchase order into its own local database. So it's persisted. And at the same time, it would like to send out a message to, let's say, the shipment service so that we can build a shipment there. And unfortunately, oftentimes how people do this is they write to their database and then they send out a message, let's say using Kafka or Pulsar or whatever it is. And the problem with this, and that's why I'm saying unfortunately, this is not transactionally safe, right? You cannot have shared global transactions which would span your database and Kafka. So it all looks good if in the happy path, but then if things go wrong, your message couldn't be sent to Kafka, you end up with inconsistent state, right? So you have maybe persisted your purchase order in your own database, but you couldn't notify the shipment service. So the customer would never get their shipment, I guess. Or the other way around, and I guess it's even worse, you already sent out this message to the shipment service. So we prepare the shipment, but we don't have track of it in our own order database. And then it would be very weird, right? So that's a big problem. And this outbox pattern, it helps with that. And the idea there as well, you cannot do those two things, writing to your database and sending a message to Kafka in a safe and consistent way, but you can always write to your own local database. And that's the idea for this pattern there. So in your order service, or in this case, it's a shipment service. So what it does is it inserts the data in its own local tables. So that's its own local domain model with shipment details, what have you. And at the same time, it would emit this outbox message. And now there's different ways how you could do this. And one interesting way is by sending such a logical decoding message. So we would use this function, pg logical emit message. We would say it's transactional. So we want to, don't emit it if our transaction rolls back. Then we say it's an outbox message. And then again, our payload here could be whatever we want it to be. In this case, it would be just a JSON structure for the sake of the example.
So wait, I have a question.
Right, sure.
I mean, I just did 2 inserts and they already show up in the write ahead log. So why do we need more?
Right, exactly. Why do we need more? And that's a good question. And some people say we don't need more. We could just use Debezium and change data capture to capture the changes from those tables. And now there's different schools of thought, I would say. So some people say, hey, we believe in the democratization of data and like everybody should have access to all the data. We just give you access to those raw tables. Some people are like that. And I'm not saying they're wrong. It's a fair approach. And other people say, no, this is not good. This exposes our internal data models. And we want to shield the outside services, the outside world from changes, for instance, which we do to our table models. I don't know, maybe we rename some columns in our tables, and this would then break all those external consumers if we are not careful. So that's why there's this second school of thought where people say we don't want to capture those tables themselves and expose them as is to the outside world, but we rather want to have a bespoke, separate message contract, which in this case is this outbox table.
That makes sense.
Right.
And can you control access to those messages? So I can say that Debezium only reads things that are messages for the outbox and not any other message?
So that's a good question. So I guess you would have to control this after the fact. So Debezium or any CDC process which retrieves those messages from transaction log, it would have the right grants in the database to be able to do that. And when it can do that, it can retrieve all logical decoding messages, all contents from the transaction log, really. So you cannot fine-grain control that and say, okay, there's a CDC process which could just get some changes for some logical decoding messages. You couldn't do that. What you could do, I guess, is you could control it actually on a table level. So that's true. Just by means of how you set up this replication slot. So there you could say some tables can be captured, but for those logical decoding messages, that's either you can do it or you cannot do it. So I guess you would then control this in a later point, right? So let's say you stream those changes now to Kafka, and then you would set up your topic, ACLs, and all this kind of stuff.
Yeah, makes sense. Cool. Okay. So
Right.
that's nifty. What else can we do?
Right. I mean, so let's and what I want to just briefly mention. So now the question is: so we have those messages in this outbox, in those messages, and we can capture them from there. And now actually we can use stream processing with Apache Flink or tools like that to further improve the semantics there. So let's see what we can do. So first of all, this is how it could look like, to give you like a real example. So here, I have my my message there with number of packages, whatever my business data there is. And now in terms, when I model my application in terms of domain-driven design, I could have things like an aggregate ID. So what's an aggregate type? So this is about shipments, or this is about customers, and so on. And this is for shipment 42. The reason why I would want to do this is because I would, for instance, ensure correct ordering semantics, right? I want to make sure that all the messages for shipment 42, that they arrive at the consumers in exactly the same order as I have emitted them into this as logical decoding messages. So consumers receive them in the correct order, which means in terms of Kafka, I would want to use this aggregate ID as my Kafka message key, right? So they all go into the same partition. And also maybe I want to use this aggregate type as my topic name. So all the shipments go into one topic, and then maybe I have other messages there, and they should go in another topic, right? So it's a different aggregate type. And now I could use Flink, or in this case, I even could use also Kafka Connect and SMT for doing that, to implement this routing logic, let's say. And this is, just some brief example code using the Flink API, which does that. So let's see what happens. We get this aggregate type there, which we use as the topic for our producer record. We use this aggregate ID as the message key, and then we use whatever in the payload. We use this, so that would be that part here. We use that as the Kafka message value, or Kafka record value, I should say, I guess. And then we even could do things like having this ID, a unique message ID, which would propagate into a Kafka message header. So then, for instance, consumers could implement deduplication based on just by looking at the Kafka message header. This kind of stuff, right? And we would then essentially have this sort of architecture where we would have Flink or Kafka Connect or whatever to implement this routing and making sure messages have the correct key and all this kind of stuff.
By the way, because a lot of our listeners are not Java people, some are, but not everyone. Flink has a SQL, so could you do something similar with Flink SQL?
Exactly right. So you could do Flink SQL. And I have to say, this is exactly what Decodable does, right? It's a managed SaaS for essentially stream processing based on Flink and Flink SQL, which means you can define your stream processing logic. Let's say you want to do some aggregations or filtering or routing, windowing, all this kind of stuff using SQL, which just, as you say, enables many, many more people to benefit from that and make use of all those things. That's a very good point.
Sorry, so you work for Decodable. It is possible to do in probably simpler, less, different types and a lot of code way in SQL, and yet the example is in Java.
Right. So actually, what you cannot do with Decodable right now is you cannot use those logical decoding messages. Or maybe at some point you could, but you could use totally Debezium on table changes, and there's actually managed Debezium connectors for that, which then would allow you to take table change events and do then all this kind of stuff.
Got it. Right. Okay, understood.
Yes. Right. So that's the outbox pattern in the widest sense. And again, people can try out the source code. It's all there, and can play with that if they want to. So let's talk a little bit about another use case, and this is logging. So there, the idea is. I mean, there's different ways how you could go about logging, right? I mean, I guess most of the times you would write into either log files, which you scrape, or you just send messages out to something like Datadog, all those kinds of options. But still, there's another option. Sometimes it's just useful to use your own database for logging, because it is already a persistent state. So you don't you have backups for that. You have your managed RDS database, all this kind of stuff. So maybe you don't have a high volume, so you just want to use that also for capturing log messages. And you laugh. You think it's like not a good idea, or what do you think?
I have to say that I usually write my log messages to a file, maybe
Right.
CloudWatch. I
Right.
haven't so like because if I could write I mean it makes now that you mention it, it makes sense because if I write it over to something that ends up in Kafka, and then it's really easy for me to send it over to Elastic, CloudWatch,
Right.
wherever
Right.
else I need it. So yes,
Right.
this does make
So
sense.
I mean, yes, I don't think it would be like the most common logging approach or whatever, but it's and for instance, tools like SLF4j or I should say Log4j, they have typically appenders for JDBC, so they support this kind of stuff. And now, if you think about it, I mean, in particular, you want to do logging if things go wrong, right? So there's an exception, and you want to know, you want to persist the reason for that. And now, if you use your database for logging, an exception or a failure typically means your transaction gets rolled back, so you don't end up committing any data. But you still want to persist your log messages. You don't want to roll back your log messages which you write to the database, right? Because then you would not have them. And this is where those non-transactional logical decoding messages come into the picture. So let's say we have this sort of scenario here. We have two transactions. This one here. So it begins, then it's a bit bigger, does some insert into some table, then it emits some log message. So in this case, it just says, everything's good, and another data entry, and we commit this transaction. So that's the first one. Then we have the second one. It's the same thing, but something goes wrong and we want to roll back this transaction. And we also want to emit a log message about it. And here we say this should be like a non-transactional logical decoding message. We give some description there, and then we roll back our transaction. So it would be undone. And now let's see how this looks like in terms of the, SQL first again. So that would just be our transactions there. First one gets committed, second one gets rolled back. And now if you look into the changes from those logical decoding messages, so we take a look at this replication slot, we see what happened there in the database. And we can see now, okay, so this first transaction, 768, this ran successful. So we see begin and commit. We see our two insert operations. And again, that's just what you see by using this function PG logical slot peak changes. Could be via Debezium, it would be emitted as JSON or whatever in a nice structure. So that's just like a utility. And we also see our logging message. So in this case, where the content is okay. And now for our second one, this was the transaction which got rolled back, right? And this is now interesting because we don't see the actual data changes. So we don't see those inserts, which we did here and here, because the transaction got rolled back. But we still see this log message, and we would then be able to see, it hopefully would be some context which describes what went wrong.
That's pretty cool. And the key here is really to put transactional as false, as opposed to the previous where the important bit was to leave it as true.
Exactly right. Exactly. So you always need to think about the failure scenarios. I mean, we always should, I guess, think more about failure scenarios. I guess we always think not enough about it. What happens when things go wrong? How should it behave? And based on that, you would say, okay, it's a transactional message or it's not.
Yeah, and I think one of the things that makes this, at least to me, look very attractive is that it is nice to see kind of the history of what happened by just running a query. And I mean, we currently use, Drop Wizard, Hibernate, the usual Java stack for working with a database. Okay. And it's not easy to mix a non-transactional query in the middle of a transaction unless you use a trick like that, because they actually try really hard to protect you from doing weird things.
Exactly, yes. And you would then, I guess, would need to have a second connection, and then the question, how do you correlate this stuff and all this things.
And even how do you bring in a connection to a transactional context in Hibernate, which tries so hard to protect you from bringing in other random things. So.
Exactly. Yeah. Yes, I mean, so this was I know I was thinking of what could be a use case for a non-transactional logical decoding message. And I guess there's not many of those, but this could be one of them. And I feel, it's interesting to know about, and it could be a useful tool in the box to have.
Exactly.
Right. And then the last one, which I describe in this article, is audit logs. And now for audit logs, I mean, what's the story there? I mean, oftentimes you want to keep track of what happened to your data, right? So how did it change? And I mean, CDC change data capture tells you about the what did change, right? Because if you have a Kafka topic with all the change events for your tables, in this case, like customers and addresses, that tells you the history of the data. But what it
Yeah,
doesn't tell you is the metadata, right? So like,
exactly.
what's the, I don't know, the business user who did this change, or maybe you want to
Exactly.
like the client IP or client device, all this kind of stuff, because
Exactly.
you don't store this in your tables, right?
Yeah,
Um,
and actually, I was just thinking that I think like it is possible to get the database user, but this is usually not the business user.
Exactly right. Exactly. It's because you have like one application user or one database user, which I don't know is called Hibernate or something.
Yeah, exactly. Exactly. That's how connection pools usually work. Otherwise, it would be extremely hard to manage it. But
Exactly. All right. And this comes up in the Debezium community again and again. So how can we enrich our change events with this metadata? How should we go about? And again, I feel those logical decoding messages, they could be an interesting tool there for helping you with that. And by the way, logical decoding messages, and again, a bit of stream processing. So the idea there is, if you do your transactions at the beginning, you emit all this metadata which you want to have, and this could be like all the stuff like your business user timestamps and what your context should be. So you emit this. You definitely say it's a transactional message because it should be a part of the transaction. Then you do your actual changes, like all your inserts, update, deletes, and you would use stream processing for taking this metadata, keeping track of it, and then put it into all the change events which originate from the same transaction. And again, the question now is how do you do this? And this is just like a brief example of a flat map function in Flink. So just to give a context a little bit, Flink, like Kafka Streams, comes with a Java API where you can do things like joining your topics, filtering them, mapping them, all this kind of stuff. And now with the flat map function, what you essentially do is for each event which comes in, you emit 0 or n changes. So unlike a map function where you just, you get one in, you get one out, with the flat map, you can either give out nothing or one or multiple messages. So that's the idea there. And now what we would do is we would essentially say if it's a logical decoding message, and this we recognize by the type of the change event. So and this is how Debezium encodes it. So if you see it's this type M, which means like message, I guess. So we know, okay, that's our metadata message, and now we can examine this prefix and, for instance, say, okay, if the prefix is audit, so we only care about logical decoding messages which have this audit prefix. So then we will put them into some state which we store. And this is, we don't need to go into the details too much. We just we remember this state in memory, let's say. If it's another logical decoding message, which isn't an audit message, we would just say, okay, propagate it to the consumers. But for the audit messages, we have remembered what we got there as our metadata. And then if you have other messages, so it's not not a logical decoding message, then we essentially would just go to our state store and we would check if the data which we have there is it for the same transaction. So all our change events have also the transaction ID. If it's for the same transaction, then we would just take the metadata from the state store and put it into our change events. And then we write it out. And I should have an example here. So this is how it could look like. So here, I emit some metadata using, in this case, a JSON string where I say I have a user, the client attribute there. I do 2 inserts into customer and address. And then if I look at my change events, how they would look like after they are enriched, I would see, okay, that's my actual changes there, right? With the before and the after state. So before is null because it's just an insert, but here I see my actual changes there, or my inserted data. And here I see this audit data, which I took from the transactional metadata event and put it into this change event. And the same for the other one, for the address one.
Yeah, and this is brilliant because it actually allows me to do inserts normally, as opposed to basically turn everything into this logical decoded message. And
exactly right. So you can do this in one place in your application. I don't know, using an interceptor or whatever request handler, which you make sure it gets invoked early in the transaction lifecycle, and you have this then done once, and everything else can happen after the fact. Yeah, that's audit logging.
Yeah, so I have another question about audit
Absolutely.
logging. You mentioned it all depends on having a local state store with the temporary audit information for each transaction and so on.
Right.
Is it safe? I don't know. I haven't used local state stores with Flink ever. So
right. Yes. So it would be persisted in RocksDB typically. So yes, it is. It gets persisted, and then if this job fails, it needs to restart it. Then it could go to the state store, just like in Kafka streams, and retrieve the state information. So it wouldn't be lost.
Okay, fantastic. Yeah.
Yeah.
So okay, I know you have a bonus use case, but I have a question.
Sure.
Before that, do you know why is it called logical decode messages?
Why is it called logical decoding messages? I mean, so the thing is, so logical decoding in Postgres is this process essentially of giving you access to the transaction log and allowing you to provide plugins into Postgres actually, which could emit those contents of the transaction log in different formats. So, for instance, there is one. I guess by now it's the most commonly used one, which is called PG output. So this is part of Postgres since version 10, and this gives change events in a binary format, and Debezium implements that binary protocol, so we get changes very efficiently in a binary representation. But then there's also what's called wall to JSON. So that's a plugin, a Postgres plugin, which then gives you a change event feed in a JSON format. I don't think it's necessarily the best because it's quite verbose. Maybe you don't want to do it, but so that's logical decoding. It means in Postgres to put plugins there, which then can emit change events in different formats. And well, I guess logical decoding messages because it's arbitrary messages, which you can use.
Now I get it. And is Decodable name related by any chance to those?
Decodable? I don't think it is. We would have to ask Eric about it, but no, I don't think it's related to that. But this is more about being able to decode any kind of information, be it Postgres or whatever it is.
Totally accidental.
Yes, exactly. No, that's cool.
Yeah. So do you want to share the last use case? It is a bit advanced. So
do you want to hear about it? We can talk about it. Yeah, let's do it. So the thing in Postgres is, and do I have a picture for that? No, I don't. So the thing in Postgres is, you can have a physical Postgres host, like one database machine, and then you can have several logical databases running on the same host, right? And that's interesting for isolation purposes. I guess you could have different applications, and maybe you don't want to spin up their entire own database machine or their own RDS instance or whatever it is. So you just give them different logical databases on the same Postgres host. So this works very fine. The problem there is the val, the write-ahead log, the transaction log, that's shared across all those logical databases. There's one database log for the entire database. So that's the one thing. But then those replication slots, which we saw before, which is where Debezium or any connector goes to and retrieves changes from, those replication slots, they happen in the context of one logical database. So you have one global shared transaction log, but replication slots are specific to the databases. And now what can happen is if you have multiple databases on the same host, and let's say one of them receives many changes and it's active, so this database is active, logic is running against it, inserts, updates, deletes are running, and there's another database which doesn't receive any changes. And now what also can happen is you actually have a replication slot which gets connected, or which is connected to this second replication slot. And because there's no updates, or let's say just rather infrequent updates, the connector can never advance this replication slot. And the way it works in Postgres is it will retain to the transaction log segments until all the replication slots have said, okay, I have consumed the content.
So it just gets larger and larger, takes over your disk space, you pay a lot of money to AWS, etc.
Exactly right. And actually, I can go to my blog, and because I ran into this, so let's see. There is the insatiable Postgres replication slot. And it's exactly as it describes. So if you have like your monitoring on RDS, I'm saying RDS, but it could be anything, right? So you will see, okay, is this the disk space? That's transactions, I guess. Let me see. And that's the free space, right? And you see how it nicely degrades over time. And people run into this all the time. They get, I mean, you look at this and it's scary, right? Because your disk.
And remember that the disks, regardless of RDS or anything else, the disks for the transaction log are the ones that have the most impact on performance. You always want them to be the absolutely fastest disk. Writing to transaction log is always synchronous. So those are the ones where space is at a premium because it can get so expensive.
Exactly right. So you definitely want to have monitoring on that, and you should have an alerting. So if this happens, you know about it. So that's the first thing. But yeah, I mean, I set up a connector. I was playing with it, and then I saw this, and that's a problem.
It is.
And now, the logical decoding can help us with that, because what we can essentially do is we can create some artificial traffic in this database. So just to be able to acknowledge this change and say to the database, okay, this replication slot can advance. So that's the basic idea. And now, if you have some functions there in Postgres where you can say, I want to see my current val position, and I compare it to what this slot retains. You could run this kind of query, and there you would also see, okay, this is how large we fall behind, and if this gets bigger and bigger, it would be a problem. And now, yes, we can emit such a message. So we could just say, like, I don't know, into a heartbeat topic, or using a heartbeat prefix, like timestamp for the sake of the example. And now this would then be enough for the Debezium connector to acknowledge that change. And now make process with this replication slot. And actually, what you even can do this if you use Debezium, you could even put this into the connector itself. So there is a way where Debezium can run this kind of heartbeat query against the database. So you don't need to have your own application or whatever to issue this. It could be part of the connector itself every 5 minutes or so to just emit a logical decoding message, and then you could advance this replication slot. So that's definitely, I think, very useful. I realize it's quite specific, but once you have been burned by this problem, you will totally appreciate that there is this kind of option.
And I want to be clear, it's not a problem specific to Debezium. I mean, anything that has to replicate databases, which is common as a method of availability, could run into the same situation.
Exactly right. And people have this kind of problem. Let's say, I mean, it also could happen, maybe they don't they want to update a connector, and then they forget to restart it again, and then you have the situation, where this transaction log piles up and it gets bigger and bigger. So definitely you need to have alerting for that, so you know about the situation before it's too late.
Yeah. That's a good takeaway, by the way, for everyone in general. Monitor the disk space, monitor also your replication slots. You don't want to be in a weird situation there. So
exactly. Sure. Absolutely. Yes. And so if people want to try it out, so we try this out themselves. So we have this examples repo under the Decodable org on GitHub. So there's all the source code, and like the complete picture, which I didn't show today. And people can run it themselves, try it out at home, and
And
give
if
it a try.
anyone has a actual use case, like goes to production with this solution, absolutely let us know. We would love to hear about it.
Absolutely. Yes, I would love to hear it, but for for today, or generally also with the article, I just want to get out the word about this concept of logical decoding messages. I feel not many people know about it, and I think it's super useful. And yeah, as you say, if somebody puts it into production, I would love to hear about it.
Yes. So, Gunnar, thank you so much for joining us and sharing this apparently not new, but not very well known and potentially very useful feature in Postgres.
Absolutely. It was my pleasure. Thank you so much for having me. And again, if people have questions, they can find me on Twitter. I'm Gunnar Morling there, or send me an email. I'm gunnar@decodable.co. I'm happy to exchange about that or data in general. Looking forward to hearing from you.